Good morning, dear children. How are you all? So, let's start with our next topic of chapter number 3, metals and nonmetals. Yesterday, we have talked about the physical properties of metals and nonmetals. So, let's start with the chemical properties of metals today. First of all, to understand the chemical properties of metals, children, you have to understand one thing, like it's very important that metals and non-metals show different chemical properties. Metal atoms can lose electrons to form positive ions. Therefore, metals are said to have electropositive character. For example, let's say if we talk about the metal sodium, sodium is going to release or lose one electron to form sodium positive ion, that is called cation. That is why we say that metals are electropositive in nature. They generally lose electrons to form positive ions called cations. For example, if we talk about magnesium, magnesium is going to lose 2 electrons to form magnesium 2 positive cation. Aluminium will lose 3 electrons and form aluminium 3 positive. This you have already done in your class 9 according to the valence electrons. So let's start with the very first property of metals, that is the chemical property. When we are talking about when metal reacts with oxygen, then what happens? See children, any metal reacting with oxygen which is present in air, it gives rise to metal oxide. Here few examples are given, like if we talk about the metal copper, it adds up, it reacts with oxygen to form copper oxide, which is black in color. Similarly, aluminium reacts with oxygen to form aluminium oxide, that is Al2O3. Magnesium reacts with oxygen to form magnesium oxide. But here you have to understand one thing, that the reactivity of different metals are different with oxygen. For example, if we talk about the metals sodium and potassium, they are so reactive, they react so vigorously that they can catch fire if kept in open. So that just to avoid this fire, they are always kept immersed in kerosene oil. Surfaces of magnesium, aluminium, zinc, lead are covered with a thin layer of oxide which prevent them from further oxidation. Iron does not burn on heating, but iron filings burn vigorously. This is something important. It comes in the exam, that why is it so that iron does not burn on heating, but if we are going to take iron filings, they are going to burn very vigorously. Then if we talk about copper, just now I told you that copper oxide is black in color. So copper does not burn but is coated with black copper oxide layer. Silver and gold does not react with oxygen. Now we are going to talk about something very important, that is amphoteric oxides. Children, although most of the metals are basic in nature, but there are some metal oxides which show basic as well as acidic nature. These are called as amphoteric oxides. This means metal oxides which react with both acids as well as bases to produce salts and water are called amphoteric oxides. Here you just have to always remember that most of the metals are basic in nature, but some of the metal oxides are able to react with acid as well as with base. Such oxides, such metal oxides are called as amphoteric oxides. The best examples we have of two metals which form amphoteric oxides, which is aluminium oxide and zinc oxide. Here I am giving you the example of aluminium oxide. See children, in the first reaction it's written aluminium oxide, which is an oxide of aluminium, which is a metal oxide. It reacts with acid, that is hydrochloric acid, and give rise to salt plus water. Here the salt formed is aluminium chloride, which is in aqueous form, and water is formed. And similarly, if we talk about aluminium oxide, another property of amphoteric, that it is able to react even with the base, that is sodium hydroxide. And here the salt formed will be sodium aluminate, that is the formula is NaAlO2, and the water is formed. See children, try to understand in these two reactions. If we consider Al2O3 as base, then it can react with acid, that is HCl, and form salt and water. And on the other hand, if we say aluminium oxide is acidic in nature, then it should react with base, that is sodium hydroxide, and give rise to salt and water. So this is how we are going to explain amphoteric oxides. This means they are able to react both with acids as well as bases. Similarly, zinc oxide is very good, another example of one of the amphoteric oxides. Reaction of metals with water, now we are going to talk about. Metal plus water give rise to metal oxide plus hydrogen, and metal oxide plus water give rise to metal hydroxide. Here, if we have to talk about these examples, then we can have an example of calcium. Let's say calcium. Calcium reacts with water at room temperature to give rise to calcium hydroxide and hydrogen. And in this reaction, small amount of heat energy is also released. But suppose if we talk about sodium and potassium, these are the metals which are very, very reactive, and these metals react very violently with even ice cold water, and they form the corresponding hydroxides with the evolution of hydrogen gas. As far as magnesium magnesium metal is concerned, magnesium reacts with hot water to give rise to magnesium hydroxide, and again the hydrogen is released in this case. But if we talk about aluminium, iron, zinc, these are the metals which are not at all reacting with cold water or water at room temperature or ice cold water. They are able to react with water in the form of steam, that is the gaseous state of matter, and then they are going to form their corresponding oxides along with the hydrogen gas release. So this chart, if you will see children, it's going to be very helpful for you to understand. See, in the first box, it's written sodium, potassium, calcium. They react with cold water. Aluminium, iron, zinc react with steam. This reaction with the hot water, I've just told you, magnesium is the reaction. Magnesium is the metal which reacts with the hot water. And lead, copper, silver, gold, no reaction with water. And the most important thing, when the metals like calcium and magnesium are going to react with water, hydrogen gas is released in all the reactions, no doubt. But specifically in case of calcium and magnesium, when hydrogen gas is released, this gas is actually in the form of bubbles. And what is exactly is happening over there? These bubbles get stick to these metal surfaces, and these metals start floating. So this is something important. So they are forming the floating. They are the cause of the floating of these metals. So we say that it becomes lighter due to the bubbles of hydrogen gas sticking to the surface of calcium. Here the few examples are written. You may learn these reactions, otherwise very simple. Sodium reacts with water to form sodium hydroxide, hydrogen, and heat is released. Just now I have told you. Calcium reacts with water forming calcium hydroxide, hydrogen again is released. Magnesium with water, magnesium hydroxide, hydrogen gas. Aluminium with water, aluminium oxide plus hydrogen gas, and iron in the form of steam, of course. When it is going to react it with water, it will give rise to iron oxide, that is Fe3O4, that is, and along with the hydrogen gas release. Here you just have to learn one thing, that is the key point, that in all the reactions hydrogen gas is definitely going to be released, but you have to understand one thing, that which metal is going to react with which form of water, whether it's a cold water, tap water, ice cold water, hot water, or the steam. Now, if we talk about the reaction of metals with acids, specifically the dilute acids, metal reacting with dilute acid, again the same, salt and hydrogen gas will be released. And here you have to see copper, silver, and mercury. these are the metals which are not reacting with dilute acids. Examples are again here written. Children, see, if we are taking HCl, that is the hydrochloric acid, then whatever metal is reacting with hydrochloric acid, it will give rise to the chloride salt. We have done in chapter number 2, if you remember, the family of salts. Chloride salts, FeCl2, MgCl2, zinc chloride, aluminium chloride, in all the cases, because the acid taken is dilute hydrochloric acid. So corresponding salt which is going to be formed is of chloride family along with the hydrogen gas release. So that's all about today's class, children. I hope you have understood it, and if you have any doubts, please, you are most welcome to ask me in the Zoom class. God bless you all. Thanks.